Yes, and the recording has started. Okay. Now, uh, in the last maybe couple of lectures, we have gone through the basic and fundamental understanding of the concept of architecture, software architecture, and we have defined it more formally by understanding that architectures consist of elements, and these elements called components interact with each other via connectors, and they have styles, and those styles impose constraints. And of course, we also had a look at, component definition and connector definition and configuration and so on and so forth. Now, the other day, we stopped somewhere here and we were looking at architectural styles, some common basic architectural styles. And as I said on Tuesday, uh, you know, um, because it's software architecture in 316 is one of the many other concepts we have to go through. So I will not be going through all of them in 316, but as a sample, I'll go through quite a few of them actually, which are the basic architectural styles. And since they are categorized into different categories, I'll deliberately pick at least one from these different categories. Now, another point to understand before I go through this catalog is that sometimes for a given application, one of these styles will you select them and it will serve the purpose, and your whole application will be developed according to that style, and it will work. Sometimes, going back to my example, which I have been using from the beginning, since we started talking about architecture, the one-story house, the two-story, the 10-story building example. So sometimes, similarly, we may have, in order to solve the problem, we might have to combine, or we may have to combine different these architectural styles as well. And remember, they are the basic styles, so there's also quite possible that sometimes they will not be able to solve the problem you're trying to solve, and as a result you might have to come up with your own. Of course, we're not going to go to that level in this course, in 316 course, but we'll just go through these catalogs, and more importantly, since we're going to go through them one by one now, maybe not in the first one but later on, I'm more interested in you analyzing with me how they are different from each other, so that you are able to go on and and understand and compare yourself. Because at the end of the day, I want you as an architect, as a software architect, to be able to know that these are my tools, these are my styles, and they are suitable for which kind of application. Any questions before we move on? All good, right? Okay. The very first one we have here is something called client server, and I'm very sure and I'm very comfortable that you know what a client server architecture is. So what you think? Remember, we're going to talk about these styles in terms of components, connectors, their data types, which kind of data they pass back and forth, what is their topology, and why they are used. So what do you think? What are the components in a client server application? Remember, components are typically application specific.
Client and server.
Absolutely. Clients and servers. Spot on. So because at the end of the day, for a given application, you will have clients and servers written specifically for your requirements. What will be the connectors?
The internet.
The internet, or let's call them network protocols, right?
Right.
So yeah, so connectors will be network protocols or remote procedural calls. So basically, these are your connectors. Now, what is moved back and forth between client and servers are your basically information data in terms of parameters, return values, so on and so forth over the network protocol or using RPC. Now, what will be the topology of such a style? How it will look like?
There is a component which is the client, and there is a like connector which is the protocol network protocol, and this server, I think.
Exactly, exactly. So basically, you have clients, and you have the server here, and these clients are talking to the servers, sharing data back and forth through using network protocols, RPCs, right? Or if I have to draw it another way, I can say that you will have clients and then you will have servers. So basically, you will have a range of clients and you can have a range of servers. By the way, it doesn't have to be one server. It can be multiple servers. So you will have two layers. Okay, can clients talk to clients? I think I have asked this question again and again. Of course, we know from this style, the constraint is they cannot, right? They have to talk to the server and, you know, that's the way it will work. So it's a two level with multiple clients making a request to the server, right? Typical use of this client server is this style is something which is very popular and is heavily used in a lot of applications, especially commonly used applications and e-commerce applications and all of that stuff, mobile applications. Basically, you have applications with centralization of the data is required. So you have like a one central database located on a database server, and then you use logic, business application requirements to go on and connect the clients with the servers. Uh, so I think everybody's comfortable with this, right? I mean, this style is the probably the easiest for you guys, because that's others are also not difficult. But when I say probably the easiest, means you are so familiar with it, right? Okay. One last question on this. Do you know the difference between thin and a thick client?
Between what, Victor?
Uh, Thin and thick clients.
Between what? Sorry?
Thin and thick.
I don't think we know.
Hmm. Now, what happens that sometimes you might have seen that you have clients, right? So let's say that you have a server here and you have clients here. And these clients, they basically, they only have user interface in a sense. They don't have any logic. They don't do any calculations. They just get the data from the user, pass it on to the server. Server does all the calculations and computations, and the results are sent back to this client, and client shows it. Right? This is an example of a thin client where basically it's not doing any calculation computation whatsoever. Now, in some cases, you can have thick client, which means the client gets the data from the user, for example, and does some simple calculations locally. It doesn't always send a request back to the server. It does some simple calculations locally. And, accordingly, it sends the data to the server and gets the data back. So both things are possible. Now, this is a very important variation to client-server architecture, and this plays an important role, and it's an important design decision for you guys as architects and software designers, because especially, for example, you're developing a mobile application, In such applications, sometimes, you know, the client might have limited power. It might have limited memory. It might have limited storage capacity. While you might be developing a client server application like a Amazon.com application, where your clients will be on the web browsers, typically running on a i7 laptop or a machine, and typically you don't really care about those resources as such, right? Is this clear? The difference between these two?
Yes.
Doctor,
Okay. Yes, go ahead.
can you
Yes,
say it?
Mohammed? I can. Yeah, I can repeat it. Now, the thin one, there is no computation whatsoever on a client. So this basically this is a variation of a client server architecture. In the thin one, you don't have any kind of computation happening at the client. Because, for example, you're developing a mobile application and you realize that it does not have the capability, it doesn't have the processing power, it doesn't have the storage, it doesn't have the memory to do any calculation whatsoever. So basically you send the data back to the server every time and you do the calculations purely on the server, which is the typical original idea of client server. The other variation is the thick one. Thick means the client is thick means it has some very basic computation it can do, or some kind of logic it has. All right.
Yes.
And then the difference here is that you should be aware of it as a designer, because given the resources you can select the variation of the client server requirements.
Yes. Thank you, Doctor.
You're welcome. Okay, so again, by the way, don't really worry about these diagrams as such. They are just show you graphically the topology. This is actually taken from a software architecture book I usually use for my 416 course. In that book, he has basically a moon lander video game. So basically, if you look at the clients, they're talking about graphical displays and game logic and all that kind of stuff. But that's not the point here. The point is just to understand the structure, which you guys are quite comfortable, I believe. 2 layers, client and servers, and they talk through procedure calls, they talk through remote procedure calls, they talk through network. Anything is possible. Okay. Network protocols. So far, so good.
Yes.
Okay. Can we have a bidirectional communication happening between clients and servers?
Yes, can we have, but I
Do we
don't know
have?
what's the...
Do we have? Do we always have a bidirectional communication between
I
Not
think
always. Usually.
Not always.
Is it
I
possible?
think to send information.
Is it possible that clients only sends information to server and khalas, he says, alhamdulillah, I'm done?
Yes,
Yes.
it's possible, but it's useless, I think.
Exactly. It never will happen, right? It's always going to be bidirectional, right? Because otherwise, what's the point? Because server will not be doing any kind of, usually interaction with the end user as such. So if you're using a client server
Doctor,
application, yes, please.
what about when we post the data? Don't we pass it in one direction?
Oh, store information, like update something, insert.
For example, when a user register in a new website, he will post his information in the database, and he will not
Correct.
get anything.
Oh, okay. No, that's true. From that, he will not get any data back. But when, because since if you are using a client server architecture, which probably is the case in this example, when you're gonna put the registration information of username, password, all of that kind of stuff, usually on the client side, you display a message whether you've been successfully registered, or you get a message saying, this email is already in use, something like this, isn't it?
Yes, yes.
Right. So it's very rare. it's very extremely rare that you will have only one directional, stuff happening. A and B is from a, my question was more to do with not a very simple or not a typical example or a case, or a scenario. My question was more about, generally your understanding that when you have a client server architecture, this communication or the data sharing happening between clients and servers is bidirectional. Right. Now let's, and of course, since we have only have looked at one style, it is very hard for us to compare to even understand, what are my other options, right? So now let's look at another one, and hopefully we'll have some very interesting and inside discussion here now. The second one I'm going to share with you guys is from a category of styles, which is called data flow styles. Okay. By the way, the client server was from a category called layered styles. Right. I just picked one. There are many others, like in that category, the previous category, we have virtual machine and others as well. So here now we're going to look at the data flow style category, and the style we're going to look at is called pipes and filters. Okay. Have you heard about this style? For client servers, I was very confident. What about this one?
Or maybe is it like the same of publisher and subscriber?
Now that's different, Abdullah.
Oh.
That's different. We'll talk about this later, inshallah, probably on Sunday. But it's close to it, to be honest. It's very close to it. It's very similar mechanism, similar idea. But they're two different styles. Anybody else?
Maybe it's like channels, like you send the message and all the users receive the message.
It's like channels, like Abdullah said, publisher subscriber. So the idea is similar, but it's a different style. So maybe let me explain this one. We have separate programs which are executed. Sometimes they can be executed concurrently, but they are the point, and I need your special attention for this part. They are separate programs, and data is passed as a stream from one program to the other. Okay. Now, the components will be these independent programs, and we call them filters. Okay, so they are independent programs. While in client server, if you recall, your components were clients and servers. Here, for pipes and filter style, your components are these independent programs, and we call them filters. Now, if they are components or filters, then what are the connectors?
Pipes.
Yeah,
The pipes.
Exactly.
So maybe internet or cables.
Yes, that's a good analogy, to be honest. That's a good analogy, like the bus, like a service bus, or like, the hardware bus we have. But it's exactly the same thing, but so at an operating system level. So basically, it's all about, like a pipe. So it's a pipe. So it's like those, channels for communication for data streams. And usually this is provided by the operating system to you. So, and remember, going back to our discussion on Tuesday, we already know that these components are typically application specific, and these connectors are typically application independent. So, this service of pipe data stream provided by OS is basically, anybody can use it. Any of these programs can use them. Now, the data element, there is no explicit one as such. It's all linear data streams. So basically, it's all basically the data is moving. Now, we understand here, it's a linear stream. And as a result, the topology is what? It's a pipeline. So basically, you have a pipeline where you have a filter, one filter. It's connected to another filter. Then it's connected to another filter. Okay, and output of this program will become an input of this program, and similarly the output of this program will become an input of this program, and so forth. It's linear. The movement of the data is one directional, so it's unidirectional movement. And output of one program will become an input to the next one. The output of this one will become an input to the next one, so on and so forth. And also an important point to understand that they are separate programs. Right?
Right.
Okay. Now, the qualities we read or the properties we get from this is, of course, since they are independent programs, these components or filters in this case, since they are independent programs, they are mutually independent. So they basically are completely, their own. They have their own logic. They have their own, working. They don't really have any interdependencies between each other. And they are, we can use them to make a new application or come up with a new composed application by basically connecting these filters with each other with a set of pipes. And using these filters with the combination of pipes, we can come up with a new application. They are usually used in operating system application programming. So wherever you are doing more operating system level programming, where you're doing more, low level programming, you usually use this style pipes and filters. And it's something very relevant to the Unix shell. Anybody has used Unix shells, iOS, this Mac shells, terminals?
Yes.
Right. Anybody has used pipes there ever?
I don't think I use it.
Okay. Okay, let me give you an example, and then I'll get back to this, and I will have any more. I'll take your questions as well, and I will have a bit more detailed discussion about why I need this style. Okay. So let me first of all give you an example here. Of course, I'll come back to this, of course, because it's unidirectional. These programs are mutually independent. So complex data structures, sharing of this between filters, you need to be absolutely careful about it because it's not really, designed for such a complicated things. But it can be done still. Anyway, let's look at some examples where this style is used. You use this style, that's Unix shells, distributed applications, signal processing, where you have different kind of signals happening, especially in a telecommunication industry. Parallel programming, all of these applications they can use pipes and filters. Probably an easy example as an analogy is, I'm pretty sure you might have used when you're doing a bit of photoshopping, you use different filters, right? Even on your mobiles, right? You apply different filters, correct?
Yeah.
Yes.
Right, and each of these filters is usually, gives you a different feel, different kind of look and feel of it, right? And each of these filters are just separate filters. They don't really depend on each other, but you can apply one filter and then you can apply another filter and so on and so forth, right? So the same thing is, yeah, this is a good analogy, but signal processing systems, telecommunication systems, imaging processing systems, parallel programs, Unix shells, distributed applications, they use this specific style, which is pipes and filters. Let me show you an example here. Anybody has executed such a commands on Unix or Mac terminal?
I
Some of
executed
them.
something. Yeah, some of them. Yeah.
Some of them, which is fine. So what you think are the filters in this example?
The first one like lists the invoices,
Yes.
and the second one like specifically the August, like there's August.
Mm-hmm.
Sorted, I think.
Sort, okay. Anybody else has another take on it? Is invoice a filter? Or is the listing a filter?
Listing is
Listing is
the
the,
command, and the
yeah.
voices is the file, I think.
Yes, exactly. So this is the filter. This is the program which will do the listing for us. By the way, ls, who are not familiar here, ls is like, if you run this command, it will give you the list of files in this folder. What about in this case? What's the filter here? What's the program here?
It's like look for August.
It's looking for August, right? So is August a filter or grep is a filter?
Grep.
August is the filter.
No, grep. Because that's the command, that's the program. Remember, filters are independent programs.
Oh, I think it's filtered giving the August month only.
Oh, yeah, it will do that. Absolutely, it will do that. So let's see what will happen here. What are the pipes? Before I'll dig into this. What's the pipe here? What are the pipes in this command?
The slot. Yes, this one.
Yeah, these ones, absolutely. Of course, under the cover, this is because it's a shell. So basically, at the programming level, you're telling operating system, hey, with this command, you're telling it what? Output of this will become an input of this, right? Output of this will become an input of this, right? So what will happen? ls filter will go and take invoice as an input. It will go and do the listing. Then output of this listing will given to the grep as an input. Grep will go and find August in that listing, right? And eventually whatever that listing is returned will be passed on to sort as an input and will sort it out in a descending or ascending order, whatever. Everybody's comfortable with this example?
Yes.
Good. See, this is very simple case. Independent programs. Grep is a simple independent program. Listing is an independent program. Sorting is an independent program. They don't really have any connections between them as such, but you can combine them together with the help of the pipes, which are again in this case they are provided by the operating system to us, and basically you can do very interesting functionalities. And same thing happens in signal processing, parallel programming. Basically they can combine these different filters, these different small programs which are independent, but then they can combine them to do and get the task done. Of course, you can have some variations here in the pipes and filters. Usually your pipelines, these pipes are linear sequence of filters. So basically it will be linear like this, that you will do this first, this will be always executed first, then this will be always executed second, this will always be executed third. So it's like a linear movement. You can have bounded pipes. So these pipes can be more sophisticated, and you can have, say, for example, you can limit the amount of data on these pipes. And you can even have some typed pipes as well, where you can say, these pipes only, for example, support certain data types. So, it only does this kind of movement of such kind of a data. So all of these things are possible in pipes and filters. The biggest advantage of pipes and filter system is that, system behavior is basically a succession of component behaviors. In other words, because you can see that, one in this example, output of one. So basically, you will have a filter one, which in this case was ls. You give it an input, and output is generated. This output is used as an input for the next filter, which in our example was grep. Output is generated. This becomes an input to your third filter. In our case was what we call sort, and basically your output is generated. Maybe this advantage is a bit harsher word. Maybe the challenges are that pipe and filters are it's a batch process in a sense. Usually you will have things happening in sequence. It's a linear movement, so it will be batched. Like first command will be done, second filter will be done, third filter will be done. So it's very hard and not appropriate for interactive applications where things needs to go back and forth very quickly. And of course, it also, depends on your data transmissions. Everything is boils down to data transmission in this case. So basically, data is moving. Now, with this understanding, again, as I said, just an example of structure, topology. Don't really worry about this one. My question is, what's the difference between pipes and filters and client server now? Because now we know two of these styles. What's the difference between them?
I think in client server, you can, it works both ways, and you interact with all clients interact with the server, the same location, the same data, but pipe data flow, it's like independent programs that have same way, like one way. Just you can't go back, and you
Yes.
can't manipulate the input.
Yes, it's unidirectional.
Yeah.
It's unidirectional, and as you said, second thing is yes, Al Salan, please.
Doctor, also we can say about the pipe and filter. It's a multi. Can we say it's a multi-layer? Because it goes from one pipe to another. Or sorry, from one filter to another. But the client server is only from client to server.
That's true. That's true. So the interaction in that case was only that clients will always talk to the servers. Here, there is no such thing as servers. Everyone is an independent. Filters are all independent programs, and you can at any time in a linear sequential way. Any other observation, guys? Are you able to realize now that where the pipes and filters will be appropriate as an architecture? So what kind of applications you will start thinking about pipes and filters?
Command line applications.
Command line applications, these kind of shells, if you're writing even these kind of shells, any application which is going to use such sequence of independent programs interconnected to achieve a certain objective or requirements of an application, right? Signal processing, image processing, parallel programming, these are, and specifically where you're doing with the operating systems directly, right? Dealing at an operating system level, you will be actually, you will be using pipes and filters. It's one of the simplest styles, but it's something very, very popular when it comes to that kind of applications. Right, and I think all of us are now comfortable saying that, if you have, for example, for the time being, you only know two, then, it's very clear to you that, where I'm going to have a Unix command shell kind of an application, I'll not be even thinking about client server because that's not an appropriate one. I have to think about something like pipes and filters because that's more suitable for such application. Yes, Saud.
Doctor, can we consider the embedded systems as pipe and filters?
The embedded systems.
Yeah.
Yes, it's used there absolutely. Wherever you have a hardware and you're dealing with hardware, and these programs do us one independent task.
Okay, thank you.
Yes, absolutely. So this style is again used heavily in those kind of applications. Absolutely, absolutely. So it's more closer to hardware interactions, and that's what happens in a telecommunication or a parallel programming. You have different servers or different resources, and you're trying to now get the work done distributively and so on and so forth. So far, so good?
Yes.
Yes.
Okay. Now let's look at another one. is the Blackboard one. All right. Now, what happens here is that in a Blackboard one, you have again independent programs, and these independent programs access and communicate exclusively through a global repository which we call Blackboard. Of course, this Blackboard is not our learning management system. Blackboard is, it's the Blackboard which is about the global repository. I'm pretty sure in your 205 days, you might have come across this one, probably with the name of repository style, right?
Right.
But this is more generic, and hence we have independent programs with access and communicate exclusively via this Blackboard repository. What will be the component here then?
I think it's like a client server, but the client is using different programs.
Yeah, so they're using independent programs.
Yeah.
Right. Yes, so what will be my components?
Independent programs.
Independent programs, absolutely. Anything else?
Database.
Or the Blackboard, right?
Yeah.
Or the knowledge source. Yes, absolutely. So you will have independent programs and this knowledge source. What will be my connectors? How I'm gonna connect with these independent programs and this knowledge source or Blackboard or repository, whatever you like to call it. What will be my connectors now?
Network protocols.
Yeah,
maybe.
it can be direct memory accesses, so it could be direct memory manipulation. It could be through a procedure call. It could be through a database SQL query. All of this is possible. So there are different variations you can have here. Right. What will be the topology of this system?
Two layer.
Yes, yes, to an extent, yes. Of course, we know data stored in the Blackboard, right? That's our data elements. The topology will be something like a star topology, because what we'll have here is that we will have a Blackboard in the middle, okay? And then all the independent programs are, connected to it. Yeah, from that perspective, we can think it as a two-layer as well, like the client server. But just to distinguish, and it makes more sense here to call it a star topology, because everything is connected to this Blackboard in the middle, or the knowledge source in the middle. Now, these programs, these independent programs, they connect to Blackboard. Yes, please go ahead.
I didn't get the idea. Why did we differentiate between Blackboard style and client server?
That's a good one. I was about to ask this anyway. Okay, since let's talk about it. What do you think? What's the difference here? First of all, let me complete this one. These independent programs will have bidirectional communication happening between them, right? Or maybe if you just hold on to that question for maybe a couple of more minutes, and then we'll have to talk about this one, okay? So what will happen here is that independent programs will talk to this Blackboard, and of course they will go back and forth because they need to access the information. Now, since they're going to go back and forth, these independent programs, there are different possibilities. One possibility is that this possibility, where the independent programs poll the Blackboard to determine if any value of the interest has changed. In other words, in this case, they will come and inquire. These independent programs will come and inquire with the Blackboard that the data, the knowledge, the information I'm interested in, has it changed or not? Other possibility is the Blackboard itself is more smart and understands that which component is accessing which part of the data, and it will notify it if something has changed, which is this variation where the Blackboard notifies the interested components of any update in the data. Before we do the comparison with clients and servers, maybe let me ask this question: why we are interested in these? Why on earth we want these programs to poll or Blackboard to tell the components of programs that data has changed, knowledge has changed, some information has changed? Why?
Maybe to reduce the time to check it. Like every time I check for it.
Anything else?
To know who is responsible for getting the data.
Okay. What about the
Maybe in
yeah.
one system that communicate with the repository, I am previewing the data on a screen or something. If
Yes.
something changed in the repository, I need to change it there.
Exactly. Spot on. Spot on. So you need to be persistent. You need to be aware of the latest update in the knowledge, in the data, right? Information, right? So that you know you're completely consistent, you're correct, persistent, right? And for that to happen, there are two possibilities. Option number one, which is basically the program is periodically checking with the Blackboard, you know, the information I'm interested in, is it has something changed there, or other way around, which is the Blackboard knows that, you know, this specific information, these components are interested in it, so I'll let them know as soon as something changes there, right?
Yes.
Right. Now, the key point to understand here, and this is where we will tie it up, inshallah, with the question of how it's different from client server, is typically we use Blackboard in heuristic based systems where we have heuristic problems trying to solve using an AI application. Now, let me give you an example here. Do you recall a couple of years ago, Sophia robot, which was there in Riyadh for one of the exhibitions?
Yes.
Right. Now, what is happening here is that such kind of robotic systems, basically, it has different independent programs in it. Like there is a program whose responsibility is to move the mechanical arms and feet of Sophia. And then there is a camera who is maybe, you know, only recording the videos being, you know, coming in front of Sophia. And then there is another program, which is completely different program, which is analyzing these videos and seeing detecting if there is an obstacle in the front. And as a result, if there is an obstacle, you know, it will go and update the knowledge, the information, and then, you know, the mechanical arm and the feet will say, there is an obstacle, a flag has raised, I need to stop. See what's happening here? These independent programs are using this shared knowledge, this Blackboard, this repository information to do the tasks. They are independent. So mechanical program which moves the mechanical arms is completely independent to the program which is detecting obstacles based on the video. But together, using that knowledge base, they are making decisions on the fly. And this Blackboard style is heavily used for such AI-based applications. Is this clear?
Yes, clear.
Now the question is how it's different from Blackboard.
How what?
How how is Blackboard is different from client server?
On Blackboard system,
Yes, Mohammed, we lost the voice there.
We have. Can you hear me now?
I can hear you now. Yes.
In the Blackboard system, we have multiple systems that independent from each other that share a common repository.
Correct.
But in the client-server system, we have one system that have multiple interfaces, but it's the same system, which communicates with the same server, which has the same and database.
Correct. Absolutely. Absolutely. All right. Is this clear now? The question, right? The difference. Now, another question: is this information bidirectional in both client server and Blackboard? The flow of the information.
Yes.
Yes. So from that perspective, they look similar. From a topology perspective, you can even argue that it's two-layered, or that looks. But inherently, they are completely different styles, and they are different because hence their application is completely different. And Blackboard is very heavily used for AI-based applications where you have, knowledge being gained from different independent programs, and then you're making decisions and actions based on this information. And this information, of course, keeps updating and keeps evolving, right? So far, so good, right?
Yes.
Yes.
Alhamdulillah. And I think we're running out of time here, so maybe I'll stop the recording. I'll take the attendance, and of course, if you have another lecture, please feel free to leave the session.